All right. So, hello everyone, and a warm welcome from us. My name is Robin Stransky, and today you'll also hear, as was just said, from Laura Umbach, although our whole course collaborated for this presentation. Me and my colleagues are students at the German Weather Service, and we're going to graduate next year. Today, we want to present to you the current synoptic situation, as well as the reasons for, and the impact of, the freezing rain in the south of Germany on the 14th of December. If any problems arise during the presentation, please feel free to make use of the chat function. Now, before we begin, we are um, we are quite curious where everyone is from, so please mark on this map where you currently are. You should now be able to do the comments. And if you are currently not within the confines of Europe, feel free to just write on the left-hand side. So it seems like we have a quite wide range here in Europe. So thank you very much. Now onto the main course. The first part of today's presentation will be the freezing rain, and thusly this part is gonna be held by Laura. So, Laura?
Thank you, Robin. Welcome, everyone. I start sharing my screen. Can everybody see it?
Yes, we can see it.
Thank you. I would like to talk with you about the freezing rain in southern Germany last Wednesday. I would like to start with the prehistory, so what happened before. Especially the south of Germany was affected by frost for days. There was also a thin layer of snow, as you can see here on this picture. This is a webcam picture from Hohenpeißenberg taking the day before the freezing rain. The Hohenpeißenberg is a mountain between Munich and the Alps. Yeah. Now let's move to the weather situation. On this slide, you can see a satellite picture taken on Wednesday 12 UTC and the geopotential height at 500 hectopascal. There's a convergent zonal flow over the Central and Eastern Europe. The central upper low is situated above the south of Finland. And in addition, there's an upper low to the west of the British Isles that repeatedly generates marginal lows, which subsequently move eastwards, so thus causing a low pressure zone between spanning from Britain to the Balkans and Greece. As you can see on the surface pressure chart, the upper low to the west of the British Isles is also pronounced at ground level. From said low, an undulating front extends over fronts to the low in the Alps. Here in the air mass RGB, this front is easily decelerary. South of the front, the air mass is mild and moist, as evident by the green and blue hues. To the north, the dry polar air mass is dominant, here displayed in red. As the convergent flow is moving polar air from the north and mild air from the south towards to one another, it's a frontogenetic effect. The resulting front is so quasi-stationary. During all this, southern Germany is situated in the lee of the Alps. On this slide, you can see the temperatures and wind at 850 hectopascal. With a southwesterly flow, mild air is being advected there, leading to warm air advection in 850 hectopascal. In addition to the lift caused by the warm air advection and the alpine low, there's a speed convergence in the wind field, forcing the air to rise as well. Now, in order to explain the type of the precipitation observed in this area, we are going to take a closer look at the state of the atmosphere there. This sounding is from 12 UTC and on the 14th and was done in Oberschleißheim, which is located in southeastern Germany to the north of Munich. As you can see, the air is saturated up until quite high in the troposphere. And on the right-hand side, the warm air advection can be seen in the change of wind direction. The crux of this day's conditions can be found directly above the upslope inversion. The crux of these conditions can be found directly above the upslope inversion in the lower troposphere, which you can see here. There's a layer of air spotting positive temperatures in some parts of southern Germany, reaching up to 5 degrees Celsius. Directly above, there's a saturated layer of cold air generating snow. And this snow, on its way downward, passes the warm layer, which causes it to melt into rain. And this is immediately followed by the cold layer below, supercooling the rain. As a result, the supercooled drops freeze immediately upon impacting the ground. This freezing rain is displayed here in the red squiggly lines. As you can see, it was reported throughout most of southern Germany. Interestingly, the region along the southern Germany's west border, where the Black Forest is found, has multiple mountain stations reporting non-freezing rain. Where they are, the thickness of the cold ground layer of the air wasn't enough to supercool the rain, or another way to achieve the same result is that the height of the mountains caused the reporting station to be situated inside the warm layer. Also notable is the snow that's reported in the north of Bavaria. This area is too far away from the maximum of the warm air advection to have a warm air layer able to melt the snow in the first place. This synoptic situation on the 14th December caused a vast array of restrictions in public life. On the left, you see the reports made by the public in the official German Weather Service app. In addition to a multitude of delays and cancellations in the German train services, local and long-distance traffic, there were also significant traffic obstructions on the road. During the early afternoon, even the air traffic of Munich airport had to be restricted and partially closed for several hours. This was because it wasn't possible to de-ice the runways and aircraft due to the steady freezing rain, making it impossible to ensure safe flight operations. As a result of the rains, dangerous black ice conditions set in between the Black Forest and the Alpine foothills. By the afternoon, there were already 250 weather-related deployments of the emergency services in the city of Freiburg alone. That's near the Black Forest in the southwest of Germany. 15 treatment stations were set up in a kind of makeshift hospital in a large exhibition hall in the city in order to relieve the emergency rooms of the area's clinics which were overloaded mainly due to the black ice. In response to an inquiry made by a German television channel, Freiburg's University Hospital said on Wednesday afternoon that its emergency room was at maximum capacity. At the time, about 80 patients were being treated for injuries related to the icy conditions, such as broken bones and bruised heads. The Red Cross said that injured people would be medically treated there and transported on as soon as another suited clinic would be able to admit them. In the Munich area, there were numerous weather-related delays and cancellations on the railroads. Many long-distance trains were cancelled altogether. The ones that weren't were delayed severely or would only service a part of their intended route. In regional transport, many lines were completely suspended because trains could no longer make headway on the slippery rails, and some came to a standstill on the open track. Multiple trains had to be evacuated with great effort and significant waiting times. In all this, Munich airport was quite hard hit as well. While the morning flight operations were barely disrupted, all takeoffs and large number of landings were cancelled from 12:30 p.m. until 5:30 p.m. local time, according to data from flightradar24.com. The aircraft were in part rerouted to Linz, Vienna, Stuttgart, Nuremberg, or Frankfurt. Others didn't even depart on their journey towards Munich. More than 160 employees were on duty to de-ice aircraft and operational surfaces, trying to ensure safe flight operations. Even the day after, the impact was undeniable. Many aircraft and crews were still not where they should have been according to their flight plans. And while this did cause additional delays, at least it caused fewer cancellations than the freezing rain. To end this topic, a little overview how the weather situation went on. First up, as a reminder, the surface pressure chart from Wednesday 12 UTC. We see the frontal zone in the north of the Alps. In the evening, the cold air continued its move southwards, thus the snow didn't melt anymore and fell to the ground. Here is the surface pressure chart from Thursday 0 UTC. One can see that the air pressure got higher and the frontal zone moved more southwards. On Thursday, a high pressure system got more dominant in southern Germany. The Danube divided the weather activity into two parts. North of the Danube, the precipitation stopped in the morning. South of the Danube, freezing rain and snow continued to fall. Yeah, that was it about the freezing rain situation. Now we go on with Robin.
Thank you very much. So now we are going to continue with the current synoptic situation. Here, the general how did we get here? Let's start with a satellite loop from 0 UTC until 7:30 UTC. You can already see a distinct cloud band spanning from Spain to France. And another thing I thought was quite nicely illustrated here is the southwesterly current dominating Western Europe. On Tuesday, the 20th of December 2022 at 6 UTC. A pronounced low pressure system is located in the North Atlantic, south of Iceland. A frontal system is attached to this low. Its cold front extends from the south of Sweden northwest to Cape Finisterre at the western coast of Spain. The system's warm front spans from the Baltic to Romania. The trough axis runs from the low situated to the west of the Iberian Peninsula to northern Morocco. Located in this trough is colder maritime air of polar origin. On its southern front, it causes a southwesterly high-altitude current that transports warm subtropical air to Central Europe. This pressure system moves eastwards as a whole. To the east of the frontal system, there is a ridge spanning from Algeria to Russia, which causes the descent of air above southeastern Europe. Where there is a moist ground layer, fog is created. Meanwhile, there is a trough to the east of the North Russian ridge. Embedded in the structure is an upper low located over Turkey. Lastly, as you can see on this slide, a subtropical dry air mass is present in the Mediterranean region. All this leads to the formation of a weak, truncated jet over the English Channel, with a maximum wind speed at 110 knots. Here you can see the air mass RGB. To the west, you can see the blue-hued polar air mass, as well as the red-hued dry intrusion belonging to the low to the northwest. Its fronts are quite clearly visible in the high clouds in the white, but in the 24-hour microphysics RGB, those high clouds are even more apparent in the intense red color. Also notable are the pink hues to the south and southeast, signifying the cloud-free areas of descending air in those high-pressure areas. Then, here, you can see the geopotential height at 500 hectopascals, the relative humidity at 700 hectopascals, as well as the simulated weather. And as you can see, inside the North Atlantic cyclone, you can find rain showers and embedded thunderstorms. Those are the result of the mild temperatures of the North Atlantic and the cold air masses above. Combined, this leads to high-reaching convection. The associated precipitation covers an area stretching from the west coast of Ireland through northern Scotland to the Orkney Islands. The cold front causes convective precipitation, with embedded thunderstorms being dominant along the west coast of the Iberian Peninsula. The frontal system's point of occlusion is situated above the south of Sweden, bringing with it an extensive area of precipitation, taking the form of freezing rain. A bit more to the west of this area, the precipitation takes the form of rain, while some more northerly areas experience snowfalls. The warm front runs southeast from the occlusion point, reaching into Romania. When passing through, it first causes snow, which is then followed by freezing rain. Said freezing rain is caused by rising air in the middle heights, rising warm air, and the snow created high up melts, only to freeze upon reaching the surface because of the cold air at ground level. Then, a bit further south, under the influence of high pressure, the nocturnal cooling, combined with the moist ground layer, results in increased fog formation. Due to the low temperatures, it is quite possible for that fog to freeze. Meanwhile, in the Gulf of Lion, the Rhone Valley, as well as along the Ligurian coast, the activity of rain showers is increasing, which is caused by the difference in temperature between the Mediterranean Sea and the cold air above. The showers are transported onto land by onshore winds and then additionally get reinforced by their position in front of the trough. Above Turkey, the previously mentioned upper low is responsible for precipitation, which, in some areas, is convective in nature. Due to the low temperatures, this precipitation mainly takes the form of snow. This low, working together with the high above Italy, creates a northerly current above the Aegean. It transports cold polar air from farther north into the area. And due to the channeling effect between the land masses, gusts of up to 80 knots occur. And here you can see quite nicely the way that cold air is drawn down into the south. Then, in the time leading up to 12 UTC, which you see here, the low above the North Atlantic moves eastward, still being responsible for active convection. The accompanying frontal system, similarly, moves towards northeast, taking its precipitation with it. The fog that developed under the influence of high pressure either dissipates due to the sun's influence or gets lifted, turning into a thick, low-hanging stratus. At the same time, the low above Turkey moves in a southeastern direction and its precipitation lessens. Going further forward in time to 18 UTC, we see that the entirety of the synoptic situation has moved eastwards. Now, the cold front lies on a line from southern Sweden to Luxembourg to Spain. The warm front spans from Finland towards the Baltic states into the north of the Ukraine. In the afternoon, the clouds over the Balkans clear in the majority of the regions, actually, and this is followed by the growth of a ground inversion in the evening. Underneath that inversion, fog as well as freezing fog develop. Until 0 UTC, you can see the pressure systems continuing on their move eastwards. Tomorrow, the cold front passes Central Europe. Behind it, more precisely in Great Britain and along the western coast of France, widespread convective precipitation occurs. Meanwhile, over the Balearic Isles, shower activity passes over. And this precipitation then reaches Italy throughout the course of the day. In the Balkans, the fog continues to build, once again either dissipating throughout the day or simply being risen from the surface. And last but not least, the upper low over Turkey continues on its slow move towards the south. Now, this brings us to the end of our presentation, which only leaves us to say we wish you happy holidays and thank you very much for your attention.